For examples 3 and 4, we are given an infinite sum, and it's written in sigma notation this time. So as a bit of a review, what this is saying is that when n is equal to 1, so we're starting at the first term, right? That's what we're saying here. And it's going to infinity. Okay? And then when it's written in this form, we can actually see our first term would be 4 over 5. Our common ratio would be 1 over 3. And then it's going to be to the power of the term number minus 1. Okay, so what this would do is this would be 4 over 5. And then it'd be multiplied by 1 over 3 would be our next term. Multiplied by 1 over 3 would be our next term, and so on, right? So right from this, we can actually see our values. So this would be, okay, this would be our A value. And this would be our R. And we know that as long as the absolute value of R is greater than 1, then our series is going to be convergent. So we can use our formula. So we'll say the sum at infinity is equal to A over 1 minus R. And then we'll just fill it in. So our A value is 4 over 5 over 1 minus 1 over 3. So now it's getting a little bit messy. We just got fractions over fractions, right? So what I'd like to do is kind of put brackets around each part just so I can kind of like see each, the top, the numerator as one section and the bottom is one section. So let's figure out this fraction on the bottom here first, right? 1 over 1 is the same thing as 3 over 3, right? So 3 minus 1 would be 2. So this is really on the bottom the same as 2 over 3. So let's do that. So this is really 4 over 5. Like I said, like in brackets, over, and then this is the same thing as 2 over 3. All right, so that made it a little bit better. And now when we're dividing by a fraction, that's the same thing as multiplying by the reciprocals. So we're going to now write this as 4 over 5 times 3 over 2, right? Flipping it upside down. Now, just simplifying this, I can cancel the 4 and the 2, so that becomes a 2 up there. So now 2 times 3 is 6, and then we still have a 5 on the bottom. So the sum at infinity is equal to 6 over 5. Okay, now for the second one, so let's do the same thing, but so we can see that from the beginning here, our A value is negative 2 over 5, so that's fine. But now look at our R value, 5 over 4. That is greater than 1, right? 4 over 4 is 1. So since this is greater than 1, our series would be divergent, and it never would converge on a single number. So in this case, we'd say that the series, or the sum of the series, does not exist.